This conference will now be recorded.
All right, so everybody should have access to the class. We're all on the same page now. I spun up an instance in Google Cloud just so, just to have, but we're gonna go through one of the labs I think would be useful to go over and whatnot. So you just do on a PS minus AUX or PS minus AUX. And let me expand this. And they're gonna go over this in the class a little bit more, but when we're talking about what processes are running, um, you want to be able to tell what process are running. But in a class, let me do this. I want to pipe this over to, let's just give us the first uh, 12 lines, right? You can see here they talk about the user that's running the process, the PID that's running this process, the percentage of CPU and the percentage of memory used, virtual, I think this is virtual memory. I gotta double check that. Don't quote me on that. TTY, what it got started up on, in terms of like TTY will be the terminal, the status, the start time, and the command, and I forget what RSS is. I forget what RSS is. So we're gonna learn those things today, but you're gonna also learn. Let me tell you this now: the one processor that you don't want to kill on a system is the PID of one. This is in the boot during the boot process of Linux. This is the last process to run. This is also the process that if you kill, you're gonna kill your box. So this PID of one, you don't want to kill that because that's gonna kill your box, right? All right. So and I just did a head minus 12 because I didn't want it to scroll off the screen. But we're gonna learn about what each one of these do, right? So like all in true fashion, there's always a man page for PS, right? And so PS is a report or a snapshot of the current processes, right? And this is important because you can have somebody running a job on your system that's pegging the CPU or pegging the actual memory, or causing you to, or is causing to the system to start thrashing, and or running out of disk space because it's constantly writing, so it's something that's going on the system, right? And so you all always want to be monitoring that system. Another thing too is what you want to do is find out the uptime of the system to see how long the system has been running. This has only been up for 7 minutes when it got started, and it also tells you the load average here. And there's a meaning to each one of these particular positions, right? And then if you want to do like a W to see who's on the system, all right, and then you can do a man on W, see who's logged on the system and what they're doing, right? So if I did a W, it'd tell you exactly what I'm doing on the system. And what's cool about uptime, if I was doing something on the system, these will actively be moving, changing numbers and so forth, right? So then there's PS minus EF or EF, right? Where it could tell you the user, the log name, my home directory, and so forth, right? A little bit different than the PS AUX. But again, all that can be learned by doing a man on PS, right? So we can drop down in here. It says, note that PS minus AUX is distinct from PS AUX. The POSIX and unit standards that PS minus AUX print all processes owned by a user named X, as well as printing all processes that would be selected by a dash A. If the user named X doesn't exist, if the user named X does not exist, this PS may interpret that command as PS minus AUX, well, PS AUX. So let's go and look at the difference here. Um, so PS AUX. And let me do the first 12. And that's what my first 12 look like. And so we're gonna leave that right there. I'm gonna pull this down some. Clear that. Let's do first 10. And then we'll do with a minus in the front. All right, so let's see, do we see any differences? I don't see any blaring differences right now, but I didn't filter out everything. So let's clear. Well, let's do an up arrow. No, that's clear. And let's do a tail on the last 10. And then let's do a tail on the last 10 with a minus in front. Do we see any differences in the output? I'm looking for differences in the output. Not seeing any differences in the output. Not nothing that jumps out at me. Right? So where was it at? Where was I at? Yeah, I was here. Oh, I was at demand page. That's what it was. Right here. By default, PS selects all processes with the same effective user ID, EUID, as the current and associated with the same terminal as the invoker. Right? So let's get down here to the options that we were using. To see every process on the system using standard syntax and then using BSD syntax, they're showing you the difference, right? So they're just the syntax difference. To print a process tree, so we can do PS AJXF. Let's grab that. Let's see. And let's do this. All right, so let me clear. You can see the tree. And I'll pipe this over to Les. So it's showing you on my right hand side right here the tree, like what comes under that. All right, so here we have that, and then here, right, and here's SSHD login, and then the SSH and so forth, right? So just showing you processes under that process, right? Parent and child process. And then we go back to man PS. You can use the space bar to go down one page. So I just used the space bar to go down one page here. To get info about threads, to get security information, PS minus E0. And then they got all this information here. But let's just do PS minus EM. All right, so you see here it's giving us SE Linux information. But here's another thing too. We can do get enforce. And that's tell us it's enforcer mode and it's running. And also if we did ls minus LA, the period lets us know that also SE Linux is turned on, right? So we knew that SE Linux was turned on. So when we did a PS minus EM, it gave us the actual context of the processes, right? Um, and whether and what user and I forget the name of the middle one. Contact, yeah, I guess it's the context that it's running in, and then the permissions on that, right? We're gonna go over SE Linux. I don't think they do SE Linux in 124. I don't think they do it in 124. All right, so let's go back to PS minus let's go back to the man page of PS. And the reason why I'm showing you the man pages because you're gonna need to learn how to use these on the exam. So here, if you want to see the process, every process the running as root, you can run this PS minus U root dash U root. So what does the capital U do and the dash and the little u do? So here we can do a search on dash capital U. It's the user list or it's select by the real user ID. It selects the process whose real username and so forth. And then here's another user list. So this is the real user ID and the effective user ID. So that's what they're using there. So let me go back. And that's what they were trying to show you right here. And then they just give you a list of how to use the process like the minus A, the U, and the X, right? They give you that. And then let me see. Let me do that. They're trying to see if they give you a list of the processes is what I'm looking for. Okay, so uh, CPU header. Here's the headers that we saw across going on, but this is AIX format, but we saw these going across the top. Right? CPU, the memory. Let me see if they got RSS in here. CRSS, RS size. So we gotta look for RSS. Okay, here it is right here. Resident set size, the non-swap physical memory that a task has used in kilobytes. So this is what we saw going across the top. And then you also see these throughout various processes as they get described. So they're showing you that. All right. So that's on a real live box. So in the class, we said we're gonna get information about programs running. We're gonna use a bash job to control and manipulate processes. We're gonna describe what the load average is and determine the process responsible for high resource use on the server. And then in here, in the sections, and when you got the quiz and the 3 guided exercises, you're gonna peg a machine and then have to kill the process. And then you're gonna monitor processes as well too. And then you have a lab. All right, so here, after completing this session, you should be able to get information about the program running on a system to determine the status of it. And when they're talking about the status, when we did a PS, AUX, depending on the style you want, they're talking about this particular area right here. This is the status of it, right? And then here's the user that's running that, right? And then here's the memory and the CPU of that user, and here's the process or the actual, the processes that's running by that particular user, right? And users don't have to be users that log in. Remember last week, I showed you when you go into Etsy password, and everywhere there's a no login, those are services that can be ran on the machine that will show up as a process inside of your Linux box. So it could be very well that you have a process running called SSHD. You have a process called PolKitD. This is the one that was talking about that was a vulnerability that needed to be patched. Right, it's standard in most Linux operating systems. So we had 2 big vulnerabilities for the last 2 weeks. Right. And then here's another one here, mail. And then you have FTP, but that doesn't necessarily mean they're running right now. And you're gonna find this out in the next chapter, but we're gonna kind of hit it early. All right, so when we do system CTL dash, and I think it's not dash, I think it's list dash unit files. So let me do that over in a pipe command. Well, let's do a head dash in 10. Right. Oh, my color goes away. That's fine. And color goes away. And let's leave the color. All right, so I like the color. All right, so here we have cronny service enabled, right here, cronny D. And then we have some other one with firewall D, some other stuff with cron D, and then audit D. But now let's go back and look at Etsy password. And then let's look at cronny. So here's the service right here. So it's running and there's no login. All right. So now let's go and then let's clear my screen and let's do a PS AUX and let's grep. I'm using grep dash I. I want to ignore case and let's look for cronny. Let's see. Right. So there's our servers right there. With a PID is 764, right? And that's the user right there. So we've identified in our slash Etsy password file, there's a username, Cronny, that is running this chronic D service or process. And we also identified the PID for it, and we noticed that it was enabled as well too. And so you can also do a system CTL status of chrony D, and you'll see it's active and it's running. Right. So this is just ways to find out, like, okay, does the service have a user? What should that user be? And this is another way to tell if somebody is exploiting your box too. So suppose somebody came in and added a service to your system, and inside of your Etsy password, maybe it should have been something else, like, I don't know, Chrony D. Instead of the user being Chrony, it's something else, right? Just little things to look out for. You can use things like aid in order to keep track of, files being changed or not. So just a little something like that. All right, so here they said a process is a running instance of a launch executable program. A process consists of an address space allocated in memory, security properties, including ownership, credentials, and privileges, which we saw, and one or more execution threads of a program and the process state, whether it's running a zombie process or so forth. The environment of the process include the local global variables, a current scheduling context, allocated system resources such as file descriptors. So when we talk about file descriptors, we can also start talking about inodes. All right. So when I talk about inodes, let me go to slash temp. I know there's something in slash temp and something in slash etc. Now if I do ls minus l, I see I have some files and I have two directories. Everything on the Linux system gets an inode. So if I did a ls minus il, you see now over here, instead of it showing like the permissions here in the first column, I get the inodes of the system, right? So you like, Tamika, what is an inode? All right, what is an inode? All right, so I like to use Red Hat's definition because that's what we're studying. Doesn't matter, but for your sake, let's stick with what they're talking about. Let's see, because you can run out of inodes. Oh, I don't want to know. So when do you run out of inodes? So you know all those little web servers that people spin up on one machine, and they just start serving up web servers on these one machines and stuff like that. Little bitty text files can cause your machine to run out of inodes, right? Look at that, no free inodes. Let me see if they give a definition here. Here we go. No, they don't give a definition. Ah, so by definition, I stick with this. Is an index I know it serves as a unique identifier for a specific piece of metadata on a given file system. Each piece of metadata describes what we think of as a file. That's right. I knows operate on each file system independent of the others. Right. So then when they were saying file descriptors, that's what they were talking about. Right? Here's your I node. Like that I node is unique to that machine. That I node is unique, not the machine, but that script or that particular file. Same way with this directory again. Right. So now I'm on the right one. Nope, I'm on the wrong one. Push it down. No, I'm a little bigger. That ain't the directory. I'm right here. Right here. All right. So here they're trying to show you what a process is. Remember when we did that process tree and we was able to do like I think it was PS minus EM, was it? No. Let's go man on PS. What was that? We'll look at a process tree. PS minus EJH. Let's do that one. All right. They don't do like the other one does, but you can see here SSH bash sudo's su bash ps. These are the processes I run, and it's they're showing basically it's under a thread. If we go back and look under, if we go back here and do process tree, we'll grab the other one so you can see exactly what I'm talking about. I think I did this one. Did I do that one just now? Yeah. Back. So you can see how the process is what they're trying to show you a fork and what the parents are to visually see it. So here we go. You see, this is what I'm trying to show right here. See that? All right, so here, oopsie, I was on the right one. So here we have the process. You have the parent process and you have a child process. And you can spawn off multiple child processes, right? But they have to have a parent. And if they don't have a parent, there'll be an orphan process, and we usually call those zombie processes. But we'll read through this. A parent process duplicates its own address space for to create a child process. Sort of here. And every new process is assigned a unique process ID. That's that one when I said don't kill the number one PID. That's what I was talking about there. That's a process ID. For tracking and security. The PID and the parent's process ID, triple P, triple P, PPID are elements of new process environment. Any process may create a child process. All processes are descendants from the first system process, System D, on the Red Hat Linux box. So that, remember I did the sys control and System D. So System D, everybody spawns from that, right? And then after that, you have a parent process, and under that, you have children, or child process. The fork routine, a child process inherits security identities, previous and current file descriptors, port and resource privileges, environment variables, and program code. A child process then executes its own program code. Normally, a parent process sleeps while the child process runs. Isn't it ironic? Setting a request wait to be signaled when the child completes. So basically, when I'm done playing, I'm gonna send you a signal for you to wake up. Upon exit, the child process has already closed or discarded its resources and environment. The only remaining source, called a zombie, is an entry in the process table. The parent signal awake when the child exited, cleans the process table of the child's entry, thus freeing the last resource of the child process. The parent process then continues on with its own program execution, right? So the children go out and play, they do their thing, the parent relaxes, you know, and then when you get done, come back and I'll wake up, come out my coma. All right. So here's where it gets probably a little hairy. In multitasking on the operating system, each CPU can be working on one process at a time, at a single point in time. As a process runs, its immediate requirements for CPU time and resource allocation change. Processes are assigned to state. So when we were looking at, where'd you go? No, where you go? I know I shoved you down, but I thought I kept it up here. But nevertheless, we have it right here. We'll just open up another one. So when they're talking about what each one of these mean, there's a column that goes along with it. So Z stands for the zombie process. So what you got to remember when you're talking about the kernel, you can have a process running in the user space or in the kernel space, right? And they tell you right here, syscall and return. And then you can have, if a process is stopped, it'll have a T in it. And where are you finding it at? Well, you're finding it on PS minus AUX. This right here is what they're talking about. This stuff. All right. So here, see, I stands for sleeping. You see, these are sleep, but then you got an S that stands for sleeping, and then you got an SS. And then you have, let's see if they got another one on here, a SN. All right, do they have an S? They don't have the N on here, but we'll find out what it is. And then they have, again, they're showing you this came in, got forked, and now we got these processes have states to them, or status if you want to say. So let's go over this. So R is a task that's running. The process is either executing or the CPU or waiting to run. S is a task interruptible. The process is waiting for some condition, like, hey, I'm waiting on a hardware request so I can go do my thing. So I may be in some type of condition. The system resource access or signal. When an event or signal satisfies the condition, the process returns to running. So it goes back to R. So right here, they're describing the different phases of sleep. uninterruptible. Sleeping, but unlike S, does not respond to nothing. Like, don't wake me up. I'm out for the night. Killable. In identical to uninterruptible, but modified to allow a waiting task to respond to a signal that it should be killed. And then I is the kernel does not count these processes when calculating low averages for the user kernel for used for kernel threads, right? And then T, they have two of them, stopped and traced. The process has been stopped or suspended. And then here's another T, a process that is being debugged is temporarily stopped and shares time with the T flag. And our favorite one is the zombie. Is the child process signals its parent as it exits all resources except the process identity PID are released. And then exit dead when the parent cleans up the remaining child process structure. The process is now released completely. So here they're going to show you the top, the actual command top, right? And it says the S column of the top commands or the stat column, yes, shows the state of the process. They're talking about right here. That bold right there. And we say S, if we scroll back up here, it's a task interruptible, right? The process is waiting for some condition, waiting to do something, right? And then they give you the PS minus AUX where you have S and then R plus, right? The process can be suspended, stopped, resumed, terminated, or interrupted. All signals can be done like that. All processes can be done like that. I shouldn't say signals. All processes can be done like that. So now let's look here. We have, when we use the PS command, we have a user ID, we have the process ID, the CPU in real time already expended, how much memory the process has allocated in various locations, the locations of the process known as the controlling terminal, and the current process state. And so when you do your PS minus AUX, just trying to show you the user, the PID, the CPU, the memory, the V size, the RSS. I forget what that was just when I looked it up. I just forget just right now. TTY, the stat, the start, the time, and the command. So they're saying that you do a PS minus, well, not a minus, but PS LAX. So let's do this. Let's do a man on PS. We know L is probably listing. I can't search for L. Let's do a minus L. Let's do a search for a minus L. All right, so here, long format, and then let's do a minus A would probably be everything. Let's do a minus X. I don't have nothing there for X. So let's do PS LAX. Let me split my screen. All right, so here, let's see what changed about our status. Let's do that and type that over the head minus in 10. Let's just do the first 10. So what all did we get now? All right, so before when we were doing just a PS minus AUX, this was the difference. You see the difference there? So we get I don't know, we get something called F. I don't know if that's right or not. Yeah, we got something called F or UID, a PID, a PPID, a PRI, an NI. We get a WCHAN. So there's a difference in this command. So then let's look and see. Right here's the difference right here. They're showing you that, and then the EF. By default, PES with no option selects all the processes with the same effective EUID. Processing brackets, usually at the top of the list, are scheduled kernel threads. So these right here, right? And then the zombies are listed as existing or defunct. And the output of PS displays once. Use top for the process to display dynamically. So here, now, rule of thumb, don't run top if your machine is already pegged with CPU or something like that. Right? So if I hit top, you'll come up here, you'll see stuff in real time. The CPU, the number of minutes have been up, the number of users, the low average, the memory, and the swap, right? And we're gonna learn these right here. This is your friend, and this low average is your friend, right? Any questions so far? Pretty straightforward. Okay. All right. All right. The default output is sorted by process ID number. At first glance, this may appear to be chronological. However, the kernel reuses process IDs so that the order is less structured than it appears. To sort, you can use the -O or dash sort option when we're doing our display, our listing. So let's go back up here to the table. You're probably gonna need this. R for running, S for sleeping, or you could say skid, SKID, skid will be sleeping. T for uh stopped, and Z or X for zombie. So let's go. Let me type this out real quick. So what I said was skid equals sleeping, right? And T and X equal, what's the Z and X? Z and X equals zombie. Right. I'm just trying to give you ways to remember stuff. R this is just running. And I don't know why T couldn't be, I mean, stop couldn't be S, but it's not. So stop is T. All right. All right. So let's go to our next chapter. I mean, our next one. All right. Let's go. What state represent a process has been stopped or suspended? T. That's what y'all going with. All right. What state represent a process that has released all its resources except the PID? Look at your notes. Yep, zombie. What process does a parent use to duplicate to create a new child process? Funny. What state represents a process that is sleeping until some condition is met? Did I say D? Reset. There you go. All right, controlling jobs. All right. So when they say controlling jobs, they're talking about you can have a job running in the foreground, you can have a job running in the background, you can create you can log in and have a job running, like you want to run a batch process for 4 days, foreground, background, so forth, right? So we'll give you what's a good one I can do. Let's do top, and then I'm gonna control Z. Let me see, can I do BG? So now top is in the background. It's still running. Yeah, that's still running. If I want to bring it to the foreground, I typed FG to bring it into the foreground. I'm gonna control C to get out of it. Right. So let's run that again. I have top, I control Z to suspend it. I see that I have the number 1 right here, right? That's the job number. I'm gonna background 1, push it towards the background. You notice that it got the ampersand to put it in the background. And then if I want to bring it to the foreground, I do FG. I type FG, and that brought it up to the front, foreground, background. I could have did top ampersand, and it would run it in the background for me. And then if I do a FG, it should be doing, did it lie on me? Let's see. Do I need to do FG %1? No such job. Let's see. Still there? It probably died. Let's look and see. PS, AUX. Looks like, yeah, it looked like it died. I don't see the top running. Now I could do, we can do a man on PS and say I want to get a listing by users, right? I only want the users, I only want the stuff that's running by a particular user. I don't want everybody else, right? So that's security. So to see every process running as root, so I run, let's say I do PS. Let's do this. Let's grab this. It's multiple ways to do this. Come on. Oh man, isn't that type? Oh, never mind. Let me go back and grab it. Let's go user. I gotta look up user. I think you got to now. Right here. All right. But then I think I'm Tamika. All right. So my top went away, but we'll do this. Yeah, there it is right there. And top, and then let's see, can I bring it? That's background. Can I bring it to the foreground? Let's see. Control C. I don't like me. I don't like me now. Messed up my screen. I messed up my screen. There was, yeah, screen messed up. Control C. I can't type. At least I can't see it. Make sure. Yeah, it's in this corner. No biggie. We'll leave it. We'll go back to it. All right. So now that's what we're gonna go over in this one. All right. So now after completing this section, you should be able to use a bash job. So eventually you're gonna have to learn how to write bash scripts. And you're gonna get that in 134, but I'd suggest you start learning bash scripts now. And when I say writing bash scripts, I mean little simple things like let's see, let's vim print dot sh, and then we just wanna print something to the screen right now, and you can just do echo hello. All right. The thing with bash scripts is you want to make sure they have a execute permission. So you can do a LL. You can see I can't execute this. So now I need to do a chmod plus X on print.sh. We'll do LL again. You now see the screen and you also see execute. And so now I can do a sh print sh, or I could have did this dot slash print sh. Right? So you want to start learning how to write bash scripts now. I'm not gonna say I'm not gonna recommend you wait till 134. You can, but you can learn how to write a simple bash script to just print something to the screen. You can learn how to write a bash script to take something from a user and store it somewhere or write functions, like really basic things, right? And starting out with hello is one. So in another one, you've already learned about commands, right? So you could do echo hello, you could do a top in the background, you could do PWD, right? Let's do that. Let's see if PWD works. I may have to put it into something, but we'll find out. All right, so now we just do a sh on print sh, and you can see pwd is a command that we can run inside our script, right? So we already have commands that we can run inside our script. We can say make, we can say touch um, slash temp new file dot text, right? And I'm being real loose with this, right? Real loose. And then you could say in here ls minus temp. And so now we'll do a sh on print.sh. And now you can see that it did everything we told it to do. We did tell it to do ls on that particular directory. And then you see new file.txt is actually there. So you may want to come in and put echo statements in here and say echo long list of slash temp, so you can tell what each space is doing. Here we'll just do echo, and we'll put some spaces in there, and we'll yank that and paste that here, and then we'll undo and do that, and we'll paste here. We'll yank it. and paste. All right, so we've given our set of instructions, and then let's just do ls on temp on new file dot text, and then we'll just do sh on that. So we got our separation of stuff of the commands. Right? All right. So I just got a one quick question. Let me see if y'all remember this on slash temp on new file dot text. Let's do a ls minus l. Why are the permissions 664? We learned this last week. Why are the permissions 664? What do the permissions of a file start out with? They start out with 666. And the reason why that it becomes the hey, smiley face. The reason why it becomes the 664 is because of the UMask for that user. 002. So six from zero or zero from six, and two from six is four. So 664 is the permission. It started out with 666 and then a minus 002, and that gave us 664. What's unique about the slash temp directory? What's unique about the slash temp directory? It has the sticky bits on it, right? We learned that last week, the sticky bits. Remember that we can set the SUID and the GUID with the 4, 2, and 1. And we can say 1755. This is going to set the sticky bit on a directory, right? And then if we do like 4755 permissions, that will set the what position is it in the user, the UID on a directory, GUID, I should say. Is that right? GUID on a directory. And then if we use the 2755, that will set the GUID. Group permissions. And that's what we went over last week. That's what's in last week's class. But those things I want to recap. All right, so job control. When you're in the shell, the feature of the shell which allows you single shell instance to control and manage multiple commands. A job is associated with each pipeline entered at the shell prompt. All processes in the pipeline are part of the job and are members of the same process group. If only one command is entered at the shell prompt, then that is considered to be a minimal pipeline of the command, creating a job with only one member. Only one job can read input and keyboard generated signals from a particular terminal window at a time. Processes that are part of the job are foreground processes of the controlling terminal. So this is right here. They're saying like when I do this, this is a foreground process in the terminal. And we talked about the foreground background, right? All right, the background process is the controlling terminal is a member of any other job associated with that terminal. Background processes of a terminal cannot read input or keyboard generated interrupts. That's why we couldn't play with top because it's running in the background. It's giving you your terminal back, right? So here they're talking about the PS command shows the device name of the controlling terminal of the process in the TTY column, right? Some processes such as system daemons are started by the system and not from a shell prompt. These processes do not have a controlling terminal, are not members of a job, and cannot be brought to the foreground, right? So sleep 1,000, what do you think that's going to do? I mean, 10,000, and you need to go do a man on sleep, right? A delay of amount in time calls for the number of seconds, so 10,000 seconds. So we're going to do sleep 30 ampersand. So again, we're pushing it into the background when we do the ampersand, right? 30 ampersand. And then we're going to use our other command that we had. Where is it at? I'm just using my up arrow. I'm lazy. It's gonna give on me. That's okay. It was man on PS and user. What was it? Oh, come on, user. Sleep is done. I'm gonna go to history. I don't think it's in here. I think I closed this terminal. Man on PS. And I could do jobs, but I wanted to show you while it was running. It's right in here. That one. Effective real ID and UID. I probably just do PS minus U dash T read. Let me see. I can PS minus U T read. Typical in this case. Yeah, something like that. Okay. And then it was lowercase u to read. All right, clear. And then let's run this in the background. And then let's use an up arrow. And you can see, is it there? Yeah, right here. That sleep is there. Right there. And we can come back and check it again. It's still there. Still there. Still there. Still there. Still there. Should be done now. That's a long 30 seconds. There it is. Done. Now, the other thing we did was when we did here, we can do BG. I mean, not BG, but FG. And you see my terminal goes away. I don't have access to my terminal. So that's why you put stuff in the background versus the foreground. Because I don't have my terminal. So I have to wait for this to stop in order for me to get my terminal back. So I'll wait for that to stop to get my terminal back. It says when a command containing a pipe is set to the background using an ampersand, the PID of the last command in the pipe is used as output. And all processes in the pipe are still members of that job. So we have example, some command that's piped over the sort, that's piped over the mail, and then ampersand, and it's saying that when the command containing a pipe is sent to the background using the ampersand, the PID of the last command in the pipe is used as output. So the last command is used as output, and all the processes in that pipe are still members of that job. So here you could I could have just ran the word jobs in order to see. And here let's drop this down to 10 seconds. And then we type jobs. We see what jobs are running, and we also see it's running in the background. Jobs, jobs, jobs. It's gone now. It's done. Right. And here they're saying a background can be brought to the foreground with the FG command and the job number. They're using %1. You can just use 1. You see that works. And then here they did a sleep and they suspended it like I did before. Like I did Control Z to right here to suspend the actual command. And it just pauses the command. It don't stop the command. And then I can use because I paused it, I can use FG and 1 and push that to the background. So if I did sleep 30 right here, and then I hit Control Z, and then I do BG1, I push that into my background. And I can type jobs, and I can see that it's running. Right? Still running. Right? Now, the question becomes is how do you kill that process? Right? That's what we're going to learn. Now, jobs immediately placed in the background and is suspended. The PS J command displays information relating to jobs. So PS J. I don't like how the output was formatted. Let's clear that. All right. So the PSJ command, the PPID is the PID, the parent process ID, right? The PPID is the PID of the parent process, the process that started, forked, and forked it. The PGID is the PID of the process group leader, right here. Normally the first process in the job pipeline, and SID is the PID of the session leader. And it's normally an interactive shell that is running on the control terminal. And they're showing you with the sleep command what that is. And here they're doing the BG to put it in the background and the foreground, right? All right, so here is a guided exercise. They want you to go through and make directories and make a bash script and put stuff in the background and so forth, right? And I kind of went through that. And here is to kill the process. So let me go look at the table of contents. We got killing a process, monitoring an activity, and then we're done. These other two are a guide. Now, I know it's late, so I know it's 10 over there, and I hear y'all yawning too. So, so we can continue with killing a process. Let me look and see how much longer we got on that, and then what we got to do for monitoring the process. We could probably knock them out in the next 15 minutes, but you all let me know what you're thinking. Yes, no, move forward, or y'all want to wait for next week? I got one. I'm good. Z, you're not on mute. Is that you not on mute? Everybody on mute now. What we thinking? Everybody's good? No? Yes? We good? I mean, I'm gonna keep going. All right. Silence is agreement. Steam forward. All right. So, killing the process. Now, when you're thinking about killing the process, you're killing the process by the process ID. So we're gonna do PS. Let's do a job. Let's do our job again. Sleep for 30 seconds, ampersand. And now if I did a PS, I'm gonna do it the long way. AUX And because I know it's sleep, I'm cheating. I'm gonna grep for sleep. And I see that I have a process ID of 5889. I can do kill dash 9, and we're gonna go over this in a minute. 5889. And now when I'm gonna do a PS minus AUX again and grep for sleep, it's not there. And it also tells you that it was killed. So inside of kill, we have different signals that we can send. So man on kill, and let's expand this. Let me quit that and clear my screen again. And let's do man on kill. So here, up here, you see they said I have a signal. You have to remember the formation of a command, right? We have the command, we have options, and then we have our reference. In this case, it could be the PID, which is the number, or I can give it the name. I gave it the name. I can give it the name. I can give it the number, right? So here they're showing you what all you can do with kill, and you have different signals that you can use. So it says here, if no signal is specified, the term signal is sent. The default action for this signal is to terminate the process. The signal should be used in preference to kill to the kill signal. I did a 9. Since a process may install a handler, and this is where it gets kind of funky. Remember, when we have a parent, the parent forks and then creates the children. So, but a parent can make more children, right? So this is where it gets kind of funky with processes and so forth, right? So let's continue. All right. Most modern shells have built-in command with a usage rather similar to that of the command described, the dash all, the dash ppid, the queues, and so forth. So you can kill by up here, they're showing you the PID or the name, right? Each PID can be one of 4 things: an N, which is a number larger than 0, all processes in the current process group, a signal, the dash L, all processes with a PID larger than one are signal, and dash N where N is the larger number than 1. You keep noticing they're referencing 1. Like I say, don't kill the PID 1. Right, so dash S is the signal. We could have did a kill dash L. So we do kill dash L. It gives you a list of signals that you can use to send to kill the process or signal, give it a signal, right? So let's go back to our main page. You can similar to the dash L is similar to a table dash A. We do not restrict the command to PID conversion to process with the same UID as the present process. The dash P for the PID, and then the Q. All right. So if it returns with a 0, it was a success. If it returns with a 1, it's a failure. So that means that process is still running. You didn't do anything to it, right? So now we hop back over here. Let's go to courses. Chapter 8. Yep, we're in the right one. All right. So here they're showing you, let's go back up, different process signals. We call this no hub or hub, meaning hang up. Use a remote termination of controlling the process signal. Also used to request process reinitialization. I'm going to tell you what you're probably going to use all the time. You're probably going to use 9 and 15 and 1. Two, cause of program termination can be blocked or handled. You use Control C. You'll Control C out of something. Like if I do top and I just do Control C, I just sent it a signal. When in actuality, the signal that I sent, it was a keyboard interrupt, and that was basically a kill dash two that I sent. And then the quit keyboard quit control backslash. All right. And kill nine, cause an abrupt program termination cannot be blocked, ignored, or handled. Always fatal. Kill dash 15 causes the program termination, unlike SIG kill up here, can be asked to ignore or handle the polite way to ask a program to terminate and allow itself to clean up. You're just being rude and nasty when you're using a kill dash 9. You just mean, right? So use the kill dash 15. But if you just really want to get it rid of it, do kill dash 9. All right. Here it's saying sent to a process to resume if stopped. So you send on a kill 18. Remember, we have a status that we can look at on a process say is stop. Send it a kill dash 18. But I've never really seen people use kill dash 18. Suspend the process can be blocked or handled, which is a 19, and TSTP keyboard stop. Unlike SIG stop can be blocked or ignored, and we do a Control Z. And where do we do a Control Z at? We got our for loop. We're doing something where and we're just going on forever. We'll hit a Control Z. We'll hit it with a Control Z to do our stuff. Right. I don't have that there, but we just hit a Control Z in order to do it. All right. So here, each signal has a default action. A term causes it to terminate, a cause program to save memory, a core dump, and then stop to suspend. So here's the ones they say that you're gonna commands that sending signals by explicit request. Control Z to kill, Control C. Hold on, to suspend, Control Z. To kill, Control C, and then do a core dump is Control slash. And then in here, they also show you here, signals can be signified as options by either name for like dash hub or sig hub, or by number. So I showed you the kill dash L. Now here they're saying, hey, let's grep for a process name job, right? We're filtering using grep to filter. And then once we find that process name job, go ahead and we're gonna kill it. So let's see, what process do they have? See, that's job 1, job 2, job 3. I don't know which one was supposed to be job, but it says it's got a PID of 5194. See, this may be a typo because the job is actually job 1. And they're using kill 5194. And then when you look at it again, 5194 isn't there. And then they did a kill dash 9 on 5199. 5199 is job 2. So they're killing job 2. So this left is job 3. Here it is right here. They show control job 2. What has been killed. And then they did and then here they did a sig term on 5205. 5205 is job 3. Now they did a sig term, so we come back up here. Sig term is a 15. So they gracefully are killing the process, giving it time to clean itself up, complete what you need to do, but go ahead and come to a stop, right? That's what the sig term is. You could have did a dash 15 right here. They're just showing you that you can call the sig terms, or you can call these signals by their names themselves, right? Now they're saying what? Kill all. The command kill all can signal multiple processes based on their command name. So we did a PS minus job, and then it said can kill everything, kill all by that control has. So remember the actual process, right? That's running. Here's the command, right? That's running it. Over here, usually the first column is the user. Here's the shell, but now here's the command that's running everything. Kill everything associated with control. In our case, if we had multiple things that was running Watchdog, we could kill everything running by Watchdog. I'm not telling you to kill Watchdog, but I'm just saying by the name, by the command, that everything by Watchdog we can run that, and that's what they did here by the command name. So now there's a difference between kill and p-kill. Use p-kill to send a signal to one or more processes with matched selection criteria. Selection criteria can be a command name, a process owned by a specific user, right? And we kind of played around with this a little earlier with the effective UID and so forth. So we did the process owned by the Linux user. Is it effective or real? The GID by the group, effective or real? The parent, the child process of the specific parent process, and terminal. So here they're doing grep PS PS minus AUX or PS AUX grep pkill. So let's go here and do a man on pkill. Pkill is a lookup or signal process based on name, processes based on name and other attributes. So you can do pgrep or pkill, like pgrep dash root. You see, pgrep looks through the current processes, running processes, and lists the process IDs which match the selection criteria to stand it out. All the criteria have to match. For example, pgrep dash u and SSHD. So let's run that. Let's clear my screen. So it gave me all of the processes running by the root user and for SSHD. Let's look at to me. I have two of them, which will make sense because I logged into this terminal twice, so I got another one running in the background, right? So they're showing you that you can use pgrep. I mean, yeah, pgrep, and we got over here, let's do a man of pkill. So we have pgrep that's gonna go out and grab everything, right? So it says only list the processes called SSH and owned by root. On the other hand, root and daemon will list the processes owned by root or daemon, not and, but or, right? Give me either or of those, right? And then the pkill will send a specified signal to each process instead of listing them to standard out. So now let's look at pkill. All right, so now we did pkill control. So what they did right here, they did pkill control, grab everything, right? Pkill to send a signal to one or more processes which match a selection criteria. The selection criteria can be a command name, a process owned by a specific user, or all system-wide processes. The pkill command includes advanced selection criteria. So here we did a PS on a PS, AUX, and grep pkill. So basically, what did it kill last, right? It just terminated. Now here we're doing a PS minus or PS AUX, and we grep test. So we're looking for all processes running by the user test, right? And well, not the user, but test one, the jobs running, test one, test two, and test three, right? It's just got the word test in it. Then they say, well, pkill dash u user. User is the person that owns this particular job that's running, right? User, 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 user. So it should have killed all four of these. So P kill dash U. So we go back over here and let's do a man on P kill. And let's look for the dash U. The UID. Only master process whose real user ID is listed. And so that's what they did by the user. And then when they did a grep, it's all gone. All right, now we can administrator log users in and out. Here they're showing you that when I do a W, I can see who's on the system and what TTY they're on, right? Where they're logged in from, right? How long they've been on the system and what they're doing on the system, right? You may need to log off users for a variety of reasons, like you're malicious, won't want you on here no more, get ghost, whatever. Right? To log off a user, first identify the login session to be terminated. Use the W command to list the user user logins and current processes that they're running. Note the TTY and from columns to determine the sessions to close. All user login sessions are associated with a TTY. If the device name is of form PTS /n, like we have here, it is a pseudo terminal with a graphical terminal window on a remote login session. If it's a TTY and it's TTY 1, 2, 3, 4, the user is on a system console, alternate console, or directly connected terminal device. Right. So it means they're physically connected and logged in onto it. Right. Now discover how long a user been on the system by viewing the login time for each session, the CPU resources consumed by the current job. And remember, I said sometimes a user are logged in and they got to run a batch job. It may run forever, or they may run something and they didn't know it was spinning out of control, and so it's eating up CPU, memory, and everything, right? You want to be able to kill that particular session. You don't want to have to reboot the system. But sometimes you may have to reboot the system because it's ate up so much processes and stuff like that, and it's been running for so long. Sometimes it don't relinquish back right away. So you just need to go ahead and clear that cache, clear everything, and reboot the system. But that's not always the case, right? To terminate all processes for a user, use the pkill command. All right, so here we have a pgrep-l. Let's go back over here and look up man on pgrep. Oop, pgrep. Let's do the -l. The -l stands for list name, list the process name as well as the process ID. So list the process name as well as the process ID, and for everything for the user Bob. That's what we're doing here. So we did that, the process ID and the name, right? We did all that. And then they said pgrill sig kill. This sig kill is a -9 to -u Bob. Kill it. We ain't gracefully doing anything, just terminate that. When the process requiring attention are in the same login session, it may not be necessary to kill all of the user processes. Determining and controlling terminal for the session using the W command, right? So they're running the same thing here. And then they did a W here, -H -U -Bob. So do a man on W. And then a -8 -U. No header, no current, ignores the username while figuring out the process ID. So let's do a W here, and then let's do a W -U -H. So we don't get the headers going across. The -H, it didn't give me Then give me something else. I'm not seeing a bit what the H is doing. All right. Yeah, I'm not seeing what the H is doing. And then they did a P kill dash T on TTY3. T is probably standing for the terminal. So we're doing man on P kill. And let's do a dash T. Terminal, right? So they killed the terminal, and then they went back and said P grep dash L dash U Bob. Bob just had the bash 7391, and then now they're killing terminal 3, TTY3. And then when you come back here, you don't see anything. Now, here's the fun stuff. PS tree, let me look. Yeah, it's a command that has to be installed. And I'm not sure who owns PS tree. It may be a RPM where I can do it by itself. Yum search PS tree. No match. I wonder who owns PS tree. I used to know this off the top of my head. The process can be applied using the parent and child process relations. The PS tree command gives a view of the process tree, and we saw this earlier. PS tree minus P Bob bash and then sleep and sleep, right? So we want to kill the parent 8391. And then come up here P grep dash L dash U. All right, and then you could do a P kill sig kill dash 9, and I'm assuming dash P is probably the process for that on P kill right here. So we do a man on P kill again, and then come in here and do a dash P, the parent. Okay, that makes sense. Capital P for the parent, and then here basically is dead. Right, you send it, you grepped it, you set a sick kill on 8391. So right here it says use the parent process ID to kill all the children they have created. This time the parent bash login share survives because the signal is directed at all of its children or its child process. And then they give a reference in here to kill all right here to the man pages that kind of explain it more. And I'll stop right there. We only got one section to go. Uh, Uptime, LSPCU, real time monitoring, blah, blah, blah. I'll save it. It ain't much. We can get through it right now. But I know you want to, I think you should really want to focus in on describing what load average is. So we'll save that for next week. Because we want to play with it. I'm going to write some scripts and I'm going to kill your machines. And we're going to look at load average and explain what it means. And you should write this down because this will be a question that people ask you in interviews, and also be a question that you would want to take for yourself when you're looking at like why processes, what processes are running on machine and why it's acting the way it's acting, right? So like the moving average in 1 minute intervals, 5 minute intervals, and 15-minute intervals. Like it's getting worse over time, right? So that's what that is. And I'll stop right there.